yesterday.
Westlake Road. Johnson Pond's the one into off of Hilltop. It's kind of made a little bit of a circle.
Brian, I think we're good to go and get started.
Okay, we can get started. First of all, I'd like to thank everyone for joining us today for this week's Tech Talk series. This week we're having OpenRoads Best Practice Quarter Modeling presented by Jordan Hatfield of Bentley Systems. We originally started this Tech Talk series to kind of replace our conferences that have been canceled this year. We just wanted to keep in touch with our members and provide, divide the interest in topics and keep everybody engaged on OpenRoads Designer. So some of the reasons we came up with this Tech Talk series. There's just a few housekeeping things we need to bring up. Most of you have attended these in the past know these. This is a presentation, so all attendees will be muted. We do have the chat box working now, so if you want to ask a question, you can put it in the chat box. Or I guess at the end of the session, we can open it up for questions at the end. This session is also being recorded, so it also will be posted on the NCLUG website in a couple of days. Just remember that. Anyone wanting PDX credits, just remember that that's usually when you register on the site, you can put your registration information in there. After the session, NCLUG will be sending out PDH receipts that you have attended the live meeting. There's no credit given to those who watched the recorded meeting, just so everyone knows that. Also, just be sure to stay tuned to the end of the presentation. We'll still be giving out a drawing for a $50 gift card to Amazon or whatever Patty came up with to one lucky member. Must be online to win, so stay online. Stay online.
Did we lose you, Brian?
Did he go to mute? Did he go to mute again? Okay, we're back. How far did I get? Can everyone hear me now?
Yeah, we can hear you now.
Okay, for some reason it blipped and took me back to mute. So where did I get, Patty?
I think you just finished up the raffle drawing at the end.
Okay.
So I think we're good.
So yes, I think we just hand it over now to Jordan Hatfield of Bentley Systems, and she can. I'd like to thank everyone for attending today, and she can do the presentation.
All right, so welcome. Thank you for joining me today. My name is Jordan Hatfield, and over the next hour, I'm going to share with you some tips and tricks for creating and editing corridor models using OpenRoads Designer. So over the next hour, we're going to touch on the following topics. So we're going to look at some best practices relating to template libraries, rollover constraints. We're going to take a look at the corridor objects and some of the user interface improvements, snaps and rules, target aliasing, and then as well as look at how you can use a reality mesh in your design. All right, so I'll pause that for a minute. So we're going to take a look next at the personal portal and also the Connect Advisor. So I'm going to play this short video of how to access these tools. So in the video, it starts out by loading the personal portal, which is going to direct you to Bentley Connect. This is where you can find training or access Bentley Communities, where it is now. Bentley Communities has a search function, and that's going to allow you to quickly find how-to tips, product support, best practices, and advice and opinions from your peers, as well as Bentley subject matter experts. So we're looking at the OpenRoads wiki, and there's a lot to explore here. You can use the navigation pane there on the left to kind of jump between the different topics. There's a lot of videos here showing how-tos and tips and tricks, as well as tech notes and questions and answers. So now the video is going to show how to access the Connect Advisor. Here you will learn, find some Learn content, YouTube videos, product help, as well as some of the Bentley community sites also. So you can just simply use the search bar at the top to type in an area of interest, and then the content is going to be shown below, and it's going to list out different Learn material or YouTube videos that might interest you. So in the video here, it's showing how you can access the Learn material directly from the Connect Advisor. So they're currently loading up the Quickstart for OpenRoads Designer geometry. And again, this is coming straight from that pop-up menu for the Connect Advisor. So that can be really helpful. All right, so next we're going to take a look at template libraries and what some best practices are. All right, so the format has stayed pretty much the same between SS4 and OpenRoads. So it's still going to be an external file that you load into the software. That's not going to change, but it's going to be really your only one that works that way. So you're no longer going to have like an ALG or GPK file. But although the formatting is the same and you can open up an ITL in OpenRoads, when you first open up that file in OpenRoads, it's going to burn the file path for the feature definition into that ITL file. So the best practice here is that even though you can open up that ITL in different versions of the software, you just want to make sure that you are backing up your files and creating a Connect Edition version. So this is going to allow some flexibility when you need to, if you have an update to your workspace or you're going to a different version, that you're always going to have that backup copy that you can use. So the next slide, I believe, has a video demonstrating this.
Jordan, is there sound with that video? We can't hear the sound.
Oh yeah, there is sound.
Sorry.
Sorry about that. Let me think. It's coming through. I have a speaker that it's coming through, so I just need to think about if I can change the speaker. Any ideas on how to change where the sound comes out of? Okay, so let me try this and see if this works better.
Upgrading on ITL is quite trivial.
Can hear that. Yes.
I'll just turn it up. I'm going to turn up the volume. That should help. Sorry about that.
Upgrading on ITL is quite trivial. Just a simple save process. There's a few things you want to get right from the start. Currently, we're in a workspace that was just simply taking a DGN list from Select Series 4 and upgrading it to ORD. It brings them in with the linears, the template, the roadway, the components, and all the pertinent things a template needs to be symbolized and be shown correctly in CAD. If I open up the template library right now and pick the appropriate SS4 template library, just like that, and then just simply pick the template. The feature definition now has a path that has multiple categories: mesh, components, roadway, road, pavement. First time opening in a Select Series 4 or previous version ITL file, the software will try to resolve this path. This path will read the feature definitions available in the active file and also the DGN libs and associate those with that path just that first time once you save it. So I'm going to close that and I'm going to go to File, Save As, and effectively moving it to a Select Series 4 ORD ITL file. Overwrite the previous one. I'm going to close that up and I'm going to go open that file up in GEOPAK++. And what we can see in here, we have a feature name, structural wall horizontal. And you can see for this feature template point, you can see that the style path is written to it. This will happen for all template points and also all components within the file. Remember, this is only done the first time. Once this file has been upgraded to an ORD ITL file, it does not try to resolve them. Those are burnt into the ITL files. So keeping an additional copy of that ITL file in Select Series 4 or previous format is important, because if your workspace does change, the process could be repeated by reopening your SS4 ITL.
Okay. So another practice that you want to keep in mind is, feature definitions are very important. So that really cannot be stressed enough. They're going to dictate how something looks, how things are quantified, and also how they're going to be annotated. So in Select Series 3 and 4, you only had 3 types of features. So you had a point feature, a linear feature, and a surface feature. In OpenRoads, we have many more feature types. So we have point features, linear features, alignments. We have meshes, terrain features, and then also we have corridor features and linear template features, surface features, super elevation features. As you can tell, there's just a lot more feature types. So it gives you a lot more power when you're looking at symbologies. But when we're talking about template libraries, your templates are going to be made up of template points and components. So the component feature definition is going to be classified as a mesh feature definition. And that's what's going to be used to define the outer surface of the three-dimensional solid, such as a lift of aggregate or pavement. And when thinking about volumes for this, a volume option is chosen for each one of these components, and that's what's going to define how that volume is incorporated in the quantities. So you might define it as a design component or an existing component, and depending on what you define it as is how it's going to be calculated. Okay, then we also have our symbologies and attribution that goes along with this. So the symbology is going to be defined by an element template for this feature definition. For a mesh feature definition, the settings for this element template are going to include your basics like your level, color, line style, and weight. But you're also going to get the ability to choose a material, and that material is going to come into play when you're looking at your 3D view. The symbology is going to allow you to define how and if this can be annotated as well. So you can do a lot with the feature definitions. Looking at the feature point or the template point feature definition, now this is going to be a linear feature. And essentially what are used to create linear features are what's drawn by the template. These are going to be things like your center line, your edge of pavement, or your cut and fill lines. So from the linear features created from the template points, you can create your terrain models. So these can be created quite easily with the help of graphical filters by picking these these lines that were drawn by the template. And just as with the mesh feature, the linear feature definition has some of the same settings like level, color, line style, and weight. But what's different here, instead of a material, you're going to have a cell. So there might be some cases, like for guardrail or right-of-way lines, for instance, where you want to label a linear feature inside of the cross-section with a cell. So that's where that would come into play. And then, of course, you can add an annotation group in the symbology to be part of the symbology. So I'm just going to show this video, and in the video he's just going to go through basically some tricks on how to make sure your feature definitions are correct. You definitely want to take advantage of that active template tab that he's going to show.
Okay, I'm in the template in the example workspace delivered with OpenRoads Designer. We're going to stress the importance of feature definitions within the template library. In this case, let's first look at the wearing course. Wearing course is one of the more expensive materials within this typical section. Obviously, we want to make sure that it is pointing to the correct feature definition. So A, we have the correct symbology. B, we know what it is, any attribution. With that, we are aware of that the fact that it is the wearing course. The easy way to make sure that no other components have that feature definition, we could go to the active template, component feature definitions, and then look for wearing course. Notice that only the top wearing course highlights. We could check the intermediate courses, the base courses, and the aggregate courses to make sure that all the components within this typical section template is correct and not mislabeled in any way. So this also applies when we start looking at point feature definitions, and to make sure that they have the correct feature definition associated with it. In this case, we can look at the double solid line. Obviously, there should be only one point. We could look at the single solids. It's at the lane lines. So it's a quick way to do a diagnostic to make sure your feature definitions are correct within your template library. The other thing of note, too, is looking at the naming of the feature definition. Edge of pavements, level 4, pavement 4 being the fourth point down, 3, 2, 1. These are all separated in this way so that these points could be isolated to create different graphical filters to pull in different types of surfaces that you might need in construction to represent each course of pavement or the rough grade or any other variety of situations that you may need.
Okay, so this is a very powerful tool here to use that active template tab. And when you're in this tab, as you can see, there's some other folders that he didn't touch on. But you can also, while you're over here, not only checking your feature definitions, but you can also take a look at all the points in your template, all of your components, any in conditions you may have for display rules, alternate surfaces, there's parametric constraints, super elevation points. So there's a lot of power in this active template tab to where you can easily have a list of what, an inventory of what you have inside of your template. Another thing I like to mention when we talk about template libraries is just make sure you save often. So when you're working in an external file like an ITL, it's not going to do an autosave for you. So you just want to make sure that you're periodically, going up to the File tab and selecting Save so you don't lose any of your work. So next we're going to take a look at some of the rollover enhancements. What's shown here is a dialog you're probably familiar with. So this is the rollover point properties dialog from SS4. The next thing you'll see is up here in the top right, we have a new dialog that's being used to control the slope for the adjacent component. So we're still looking at the rollover point properties, but you can see that our box is a lot more hefty and we're going to have a lot more control over what we want to do. So looking at this top right dialog, the important part is your reference point. That's usually going to be your center line, not always. The next point of note is going to be the parent point right here. So that's going to be where the slope is determined from. So in the case shown here, the rollover point properties are being placed on a shoulder point. The slope value is being referenced from this edge of pavement point, and then the reference point controlling the rollover value is going to be from the center line. You can see the image up here. So not a lot has changed in that aspect. So this top line is defining what the shoulder is going to do on the high side, while the bottom line is showing what the pavement or the shoulder is going to do on the low side. So we have on our high side super, we have a slope ranging from a positive infinity to 0%, with a rollover value of 7%, which is going to have a -7 algebraic difference. And then on the low side, we'll have a slope ranging from 0% to -infinity, which is going to provide a rollover value of 0%. And this is going to mean that the shoulder will be the same slope as the roadway once it becomes greater than the 4% that's defined in the template for that shoulder. Okay, so in the last slide, we took a look at how you can use shoulder rollover locks in much the same way that you were using them previously, using the old dialog, just kind of set up a little differently. However, with the new dialog, you will have a lot more power to control what happens to your shoulder in the super elevated section. So looking at this slide, you're going to have a lot more control in your template, and also by doing so, you're going to be able to rely less on switches and display rules, and also corridor edits like point controls. So you'll just be having more control by using this constraint instead. But let's take a look at this slide. So on the left side, we have an uncurbed high side section of a super elevation. And then on the right side, we have the same thing, with the exception it just has a curb on the high side. So looking at this very top section on the left, we have a condition where up to, so when the traveled way is, 0% to 6%, our shoulder is going to behave much like the last example. So it's going to vary between 1% and 4%. By honoring that max breakover of 7. Okay, if I go down one section, this is where we get a little bit more complex. So we're adding in an extra point inside of our dialog. So whenever the traveled way is going to become greater than 6%, this section here, this 3-foot section of shoulder, is going to mock that same slope as the adjacent pavement. So it's going to match anything 6% and greater up to that point. And then when we break, then we'll have a 1% cross slope for our shoulder. But there's going to be a video that plays next that's going to demonstrate this and how you would set that dialog up.
Okay, let's look at an example of this rollover enhancement. Now, in this case, we have just a simple shoulder situation, similar to what we would have in SS2. So let's look at the right edge of shoulder here. I'm going to slide this to the side, rollovers, and just get directly into the rollover tool. You notice the different dialog. Obviously, that's one of the things of note. The important part here is obviously the reference point. The reference point is CL. The edge of pavement is mentioned here, so you know what slope you're looking at. In this case, we're monitoring the slope of this lane. If this slope changes, we are going to modify the shoulder as required by settings. In this case, looking from a positive slope on high side super, we would have from infinity coming down to 0% on the high side difference, which is just managing the handed curve here, more or less the positive and negative value. We have a -7 algebraic difference. On the low side, from 0% down to negative infinity, we have planar lock. Basically, the shoulder is the same slope of the road once it's greater than the 4% of the shoulder. So once this lane becomes 4%, they lock and they move on. That's the difference between why we have the high side and low side differences. So I'm going to just cancel out of this, close this, and I'm just going to go to the test tool, test vertical control. And you can see how that changes from the high side. We have the algebraic difference. It'll follow it, and then if we go to the low side, it has planar lock. So let's see this in action by simply going into the corridor itself. So right now, you can see within here, we have a dynamic section. And you can see that we have the 7% algebraic difference on the high side in this right-handed curve. And you can see the 2.2 difference, obviously making the 7. Low side, the planar lock. Now that's an easy example, and that's what we always had. So there's not much new there. So let's go to the second example. Okay, in this example, we have the more complex example there shown in the previous PowerPoint. You can see that we have a shoulder PI. So if I go to test vertical point controls, you can see that when we go to the low side, it locks. And as we go to the high side, once we get over 6%, the shoulder PI comes out, jumps out, and it locks to be planar with the road slope. And then the shoulder is then 1%. So let's take a look and see how this was built. So I'm going to set up my view to show this. And I want to show this in a way where I can put this right here, or focus, rollover, and let's see this side there. Okay, so from this point, we're again looking from the, in essence, the lane, and we're looking from the CL to the road edge pavement, as mentioned right here. So when the lane is positive infinity, greater than equal to 6%, the high side of difference is 0. So basically, when it's greater than 6%, it's going to match the cross slope of whatever the lane is. However, we have a different scenario here. When we go from 6% down to 0%, we would like that to be a -7 algebraic difference, as we saw in the previous example. So we have two scenarios, and this new enhancement allows us to switch from one scenario to another without addition creating of points, component display rules, and making of switches, and making a very complex template. So this really simplifies matters if you have to deal with your shoulders in this way. The low side is quite simple. It's just the same as we had before. Now let's take a look at the edge shoulder. First thing, notice that it's constrained from the PI and for horizontal and slope. So I'm going to go to the rollover constraints, and this time it's a little bit different. Now we're looking at the slope of the actual shoulder. So you can see the references, right edge of pavement to parent point PIR. So when this slope is from infinity down to 6%, we want a fixed slope. So basically, whenever the shoulder is greater than 6%, we want it to be -1% for the outside, which is what that spec showed before that we saw in the PowerPoint. However, from 6% down to -4%, we want the shoulder, when it's referencing this lane slope, we want it to be 0%. We want this shoulder to be continuously one slope all the way through. And obviously on the one side, -4% is the height of the shoulder, so that's arbitrary. We could actually change the number here, but it was just for display purposes. We just wanted to be a normal low side super of 0%. So let's close that up. And let's look at the example here. So you can see here on the high side super at this right hand curve, we have 78.84%. When it's greater than 7.84%, we can see that we have the shoulder PI coming out at the same slope, and then we have the -1 down. And on the low side, we have the 784, 784, 784 as we define with the rollover. So I'm going to go in here, I'm going to locate station via data point, and just as we're coming into the curve, and you can see a little bit more. As we're coming out of the curve, less than 6%, you can see that we have the 7% algebraic difference. On the low side, we're still greater than 4%, so we're still 5.38 and locked. So we're going to keep marching out of that. And you can see right now at 2.14%, we have the shoulders down at 4. On the other side, also 4%. And then we basically return to a normal crown situation, adverse crown, and back to normal crown. So this is what this new enhancements allows you to do.
All right, so you definitely want to take use of the template constraints, and you want to use them before the switches and component display rules. All right, so taking a look at the corridor objects next. So the corridor feature definitions are similar to what was done in SS3 and SS4 with project settings, except some of the what they call design setting or design stages have been renamed to something different. So now we call them conceptual, design, final, and then final with contours. And these names can be set differently as needed. Taking a look at just an example of the settings of maybe like the final with contours, this setting would allow you, or feature definition I should say, it's going to allow you to turn on contours and set an interval so that the user doesn't have to go ahead and create a proposed terrain model to see their proposed contours during the design stages. So the corridor in this design stage is going to be more detailed since it's going to be processed more. The template interval is going to be smaller. It's going to be processed at every horizontal and vertical cardinal point, and also at every control point. So in the next, there is another video coming up, and it's going to show how these settings come into play when you're creating corridors and selecting, the certain feature definition for those corridors. And then after we go through the settings, we'll do another demonstration of the user interface and how you can take use of the manipulators and also the context-sensitive menus that appear when you select your corridor. And you can quickly make edits to your corridor without having to go and grab those tools out of the ribbon. So they'll kind of just be at your fingertips now.
Okay, let's take a close look at the corridor feature definition. Under the OpenRoads standard dialog, you can see we have feature definitions, and we can see that we broke out the object types, different object types in Connect Edition out. You can see that we have corridor. We also have linear template, which is a type of corridor, but we're going to be focused on corridor, but a lot of the stuff I'm talking about would apply to both. You can see we have design. I can right click, hit properties, and within that you can see the design stages from SS4 for the processing critical sections being included. We also have some naming items for the and description for the feature definitions, because it is a feature definition, but we also brought the design stages within that feature definition. So in here you can see some additions. We have enable clipping. So if you want to suspend clipping in certain situations, you can by simply hitting true false. You also have the ability for top bottom meshes, display contours. You can actually display up the top mesh if you like. You also have manipulator settings for key station and condition exceptions and other UI improvements that I'll show shortly. So let's take a little bit of a look on how this is presented in the OpenRoads model. So I'm going to go to the OpenRoads model. You can see that we have corridors, and you can see that that feature definition design is showed up here. So if you have several dozen corridors, all with the design's feature definition, it would show up under design. Now, the handy part about this is simply by selecting it, you can see the property provider shows all the information, all the settings in that file. So you know quickly what you have without going back to the OpenRoads standard dialog to find this information on how that corridor was built. Okay, here's the first UI enhancement I like to show. And it's creating a point control. We want to basically have the edge of pavement follow this horizontal element. So I could just go to the corridor object, take that, and go here and say create a point control. I could give a range. It's arbitrary at this point, but control description. But I could locate point. In Select Series 4, I could pick it off the cross section. There's EOP. But what happens if you don't have a cross section open? A lot of the folks we've been noticing is working in 3D, so that is not available. So how do you pick that point? So basically a start, stop, control description. I'm going to locate the point by picking the 3D element. That element is EOP, and also the template geometry says EOP. Why couldn't I just pick that? That was the question we asked development. You pick it, and you notice it populates EOPR. So now you're not looking and tabbing through this large list to find that point. Some of the templates that we see have maybe even 100, 200 points there, so it's somewhat difficult. So we're going to just pick linear geometry, pick our element, and let that process. Oh, I got to pick it. Priority. And there you go. We created a point control for that edge of pavement. Now, what do we do with the manipulators for the point control itself? Well, let's take a little further look at it. You see the original location of the point control. If I select it, I can see the start and stop station. I could also get other properties off this. I could go in here. I could just simply delete it, remove it. I could get the information. I could say, oh, that is horizontal. Do I want it to be true or false? How did this corridor look originally? I don't have to go to the corridor object to do this anymore. I can get it right at my fingertips. I can just hit false. And basically at that point, the point control is still stored on the corridor object, but it's disabled at this time. Okay. There's even some more UI improvements. In this case, we have key stations. I can simply slide them up and down graphically. I don't have to go to the corridor object, key in a new station, or go to the property provider. I could do a precision key in here, and maybe I want this at 90. Just key that in, and it moves accordingly. I could check them visually. Makes it handy. This example here, we have an end condition exception. It's backbone only. I could get that information simply by selecting it. I could change the station ranges by the quick property provider, or manipulate it by just simply dragging it. It makes it quite handy. I could change what it's snapped to, and it's right there, right in front of me. But another thing I like is, how does this look originally? Especially diagnosing somebody else's, what did they do here with this? Okay, they just shut off the end conditions. Go back and turn that to be true. That's quite handy. It keeps you from exiting and entering the corridor object. Here's another example of a end condition override. Notice it's slightly different. It's a box, not a triangle. In this case, if we look into the 3D view, it is putting a wall in. So again, I could go directly to the delete it, go to the quick properties, just as we did before. But this time, since it's taking a new solution, I can simply pick the template and, oh, there's the wall solution. There's the existing solution that we had, but I replaced it with the wall. So that's quite handy. Also, a couple other things I like to show is within the corridor object. So if you did go in the corridor object, you get some more information. But one thing that was always challenging is external references. In this case, you can see it highlighted when I select it. So if I have a long list of 20, 30 references, I can select it and it shows me highlighted and how it impacts the model. Another nice thing is in the clipping, it does the same thing. If I have multiple clip shapes, it will show me, since their name is linear entity 2D, it's a microstation graphic, the name doesn't tell me as much as it should. And the likes of the fact that I might not know which one was chosen. So simply selecting it shows the one in use. Okay, And a couple other nice things within the corridor object. The same thing holds true with key stations. Selecting them will highlight them in the 2D plan view, so you know where they are. Point controls, the same thing, they will highlight, and that makes it quite handy. The other little thing here is if unlocking the corridor and then turning it back on, forces automatically reprocess. In the past, you would have to turn it on and reprocess that manually. So that's quite handy, especially if you're unlocking and unlocking. Another little item here too is selecting the corridor, like define target aliasing. It says locate corridor. Well, in the past you had to select the corridor object. Now we had enhanced it. If you pick the template, it knows the template is part of that corridor. Why does it bring up the alias dialog box for it? So that picking and choosing is much easier now also.
All right, so that touched on a lot of the user interface improvements that we have when it comes to corridor modeling. Another question that we get a lot is, where do I put my corridors? So it's extremely important to protect your design data since you're no longer keeping different design data in external sources, such as an alignment file or a roadway designer file. You need to maintain separation throughout your design still to allow for your maximum efficiency when you're working. So good rule of thumb is you want to keep your geometry separate from your corridor. You also want to keep your terrain separate from your corridor. Also, it's a good rule of thumb to have one corridor per DGN. Now, you might have a situation where you have small corridors, some linear templates. You can typically throw those all together into one DGN file. But what I'm talking about is more like larger corridors that have target aliasing or point controls, a lot of things that are going to affect processing time. So it's good to keep those separate in their own files. And then if you have a very large project, you may even consider breaking up that one corridor into multiple files. Okay. So federating your files is going to be helpful to decrease your processing time. So this is going to keep the amount of data in each file limited, and all of these things listed here, like your length, the frequency of your template drops, how you have the feature definitions defined, the size of your terrain model, all of these things are going to come into play in your processing time. So by keeping your file smaller, you can drastically increase your efficiency. Other things to consider. So by separating your files out, it's also going to be helpful when you're working with a large design team and you have multiple users that need access to the same project. It's also going to protect you from losing your data if a file were to be accidentally altered in some way or deleted or maybe even become corrupted. So there's a lot of different factors that come into play when determining the appropriate size for a corridor file. But the best practice we have here is just try to use common sense rules when determining the size and length of a corridor. And we usually recommend that each designer works within their own ITL, and also each corridor should have its own DGN. Next, so we're going to take a look at snapping rules. So in this next video, we're going to see how snaps can be used to rule a corridor edit to a graphical element, as well as switching off in conditions at intersections.
Okay, in this example, we're going to show the persist snap tool that we added to update 2. We're going to make a simple case here. We're just going to go to geometry. We're just going to draw a line here. And what we're going to do is add some key stations in, and we're going to add key stations a variety of 2 ways. The first way we're going to do it is we're going to go to our corridor, add a key station, simply pick the corridor and snap to it. And you're going to see an additional template drop created at that key station. Now, if I do this again and basically shut this off and create another key station and snap again to the end of this line, it's going to create obviously another key station at that location. and densify the corridor at that location. Now you can see those two marks. You can see the graphical manipulators, but the difference is here is this one is a persistent snap, and this one is not. Meaning this is ruled, and this one isn't. So let's see what happens if we simply pick up the element and move it. You can see the key station was moving, but notice this key station up top does not move because of the fact that the snap was turned off, and I wanted a different behavior for this key station over the other ones. In this example, we have a civil cell simply attached to a corridor here. You notice there it's not clipped, and that's because we're going to show a different methodology for clipping. I'm going to edit the template and show you what we have. It's delivered in the example workspace. I'm going to edit the template. I'm going to select a null point on the top, and basically we like to refer to as a kill, more or less a kill, to kill the shoulder and our switch to shut off the end conditions and also remove the shoulder. Sort of like an end condition override, exception the fact that the shoulder is not in the end condition, so it's a little bit more helpful in this case. Notice it's targeting match line. So I'm going to exit out. I'm going to set my active feature definition, miscellaneous match line. And we have this new tool in Update 2. It's persist snaps. I'm going to shut it off. I don't want to have a snap rule persisted to the fillet when I create this offset geometry to reflect the match line. If I do, that's basically ruled to the fillet. The fillet's ruled to the partial, which is also created from the edge of pavement, which actually comes from the corridor. So basically you're saying one's creating the other, and then you're basically modifying the corridor with this condition that we're doing, so that would make it recursive. So what I'm going to do at this point is go to geometry, offset tapers, partial. I'm going to pick the centerline geometry, and I'm just going to put a distance of 30 meters to get it off to the side. You see that's way out here, tracking the geometry. I'm going to snap to the fillet, and I'm going to snap to the fillet for the end. And you can see that offset is placed right here. And simply all I'm going to do now is go to my corridors. I'm going to go to my corridor referencing. I'm going to pick the corridor and pick the reference that I just created, the match line. That's going to trigger that null point to move and trigger display rules to shut off the end conditions in the shoulder and the location of this match line. Now this is just a template frequency in the interval. And obviously I can clean that up simply by adding some key stations here, by just going in here. And I could get close. I don't want to get exact and snap to it because obviously it's not going to do anything because it's just going to put a template drop on where I just put that offset match line to shut the end conditions off. I want the end conditions to run all the way to that beginning of the fillet. So I'm going to do that one more time. And you can see my point here that gap closes the door between the civil cell and the corridor.
Right. So next we're going to look at target aliasing and best practices regarding that. So when you use target aliasing, what that's allowing to do is override the end conditions target and then target a different, either an alternate surface, a corridor, or a piece of geometry. So the tip here is if you have a large-scale project with a lot of elements inside, the target list can be somewhat overwhelming, as you see here on the left. And it can take a while to try to find what you're looking for in that list. So the trick is if you first add the feature you're looking for as a corridor reference, and then you go into the target aliasing dialog, only what you have as a corridor reference is going to be loaded into that list, shown here on the right. So in the past, you had to first load an element as a corridor reference before you could use it for target aliasing. So this has changed now. So now you can even use it as a filter. So by adding a corridor reference, you can make this list a lot smaller and be a lot more manageable. Okay, so now working with the reality mesh. So what a reality mesh is, it's a highly accurate 3D mesh that's going to capture existing conditions. These are generally created from imagery that's captured using a digital camera. So this could be a camera that's mounted or handheld, or maybe the use of drones. And then once the imagery is collected, it's then processed, and they create a reality mesh from that. So the accuracy of this reality mesh is going to be limited by the resolution of the source photography. We'll get into how you can use this for design purposes. So you can utilize these reality meshes to design your corridor. So first you would extract the area you need for your design using the ground extraction tool. And then you're going to set that reality mesh as the active terrain so that your corridor can then directly target that reality mesh. So in this image here, it's showing a 2D view and a 3D view. So in the 3D view, you can see we have a corridor running along, and it's directly targeting that reality mesh that we're using as our active terrain. And then in the 2D view, you just see the 3D mesh that's being referenced into our 2D view from our 3D model. But next we're going to look at a video demonstrating how you would load in the reality mesh and create your corridor so that it targets that reality mesh.
Okay, we have a piece of geometry. We're going to turn on the reality mesh. And we have a reality mesh here where I'm just going to select it. I'm going to change the transparency. There we go. A little easier to view. You can rotate the view of that. You can see that's a three-dimensional mesh with the overhangs and buildings and trees extracted. So it's a classified reality mesh. So I'm going to go in there and I'm going to go to terrains. And I'm going to set active, select the reality mesh. I'm going to open our profile. First thing we're going to see is the reality mesh right here. And I'm going to formulate quickly just a simple profile here, a profile line between points. And I'm just going to map to one end to another here. I'm going to set that active as my active vertical profile. Shrink up the view, corridors. I'm going to create a new corridor here, locate the baseline, reset, and I can give it name reality mesh. And I'll pick an appropriate template. I want to pick a rural asphalt divided 4-lane PGO. Just like that. And I'm just going to lock it to start to stop. Interval 5. And then cross that corridor. If I spin this around, you can see that we targeted the reality mesh directly. And you can see we have the 2D corridor in here underneath in the 3D model, but you can see right here we are targeting that directly. I can select this and I can change the transparency to something maybe a little darker here, but you can now see with that we could go in here lastly and just change it to illustration. And that.
All right, so we're nearing to the end, and we've covered some tips and tricks relating to these topics listed here, but just a quick overview of what we looked at. So when we talked about template libraries, the best practices we covered is you want to make sure you version your ITLs when you're switching between different versions of the software. And also you want to make sure that your template points and components are using the correct feature definition. So you can use that active template tab to easily do that. Next, we looked at rollover constraints. So here you just want to make sure you keep your templates as simple as possible. So you want to utilize the template constraints such as the rollover locks that we looked at And you want to use those before relying on your switches or display. Okay, next we looked at corridor objects and the feature definitions for those, and also some user interface improvements. So you want to take advantage of the context-sensitive menus that appear when you select your corridor, and you can make a lot of edits just through that. You can also use the manipulators, graphical manipulators on the screen when making your edits to the corridor. So you can use, the key ends. You can also use the handles to drag them back and forth, and the quick properties. There's a lot that you can do just, at your cursor, so you don't have to reach up and open up the corridor objects each time. And another key point that we tried to drive through is when you're creating your files, especially when it comes to corridor files, you just want to make sure you keep those files federated and try to keep them separated as much as possible. Then we looked at some snaps and rules. Excuse me. Let me go back a minute. We looked at some snaps and rules. So there you were using persist snaps, build some rules onto your corridor edit. So you were snapping to graphical elements so that later, if those elements were to move, your snapping methods were smart, and they're going to move, those edits are going to move along with them. We looked at target aliasing and how sometimes when you have a large project, you may have a long list of elements to choose from when you're choosing an XYZ target. So by just adding what you're looking for as a corridor reference, you're going to have that list that's a lot more manageable when choosing your target. And lastly, we watched a video about targeting a reality mesh and how you can utilize a reality mesh in your design when building your corridors. Now we're ready for this slide. So I just want to thank you again for taking the time to join me in this tech talk. I hope you enjoyed it. I hope you got a lot out of it, and I hope that you can take some of these best practices that we shared, that I shared, and then also from the videos, that you can start applying those to your projects. So with that, I'll open up for any questions that anybody may have. I'm just kind of checking the chat here, see. Let's see here. The corridor is in a cut section. Will it clip the reality mesh? So you would not be clipping. It would just be like an active terrain. So it would not be anything that you'd be clipping. That would still be your existing surface, and then you would have your proposed surface that would cut through, and then your back slip would tie back into that reality mesh. So is there a good Learn Server course on the snaps and rules? So that's something I'll look into on the particulars on what that would be. I know there is a lot of Learn material. I think it's creating and editing the corridor, touches on a lot of the different snaps, but I'll look into that, and I'll make sure some links are sent out regarding the snaps and rules for corridor modeling. Is there a way to clip the reality mesh based on the construction limits of the corridor? Yes, so it would just be used as, once you have your construction limits, that would be used as a boundary, and you could use that ground extraction tool again, to clip, if you wanted to clip the reality mesh to that boundary, you could. So it's just like when you're clipping your surface, or your terrain models, is what we call them now. So when you clip that terrain model, you can use different shapes and boundaries to do so.
Great. Not sure what happened to Brian, but appreciate your your walking us through this, Jordan. It was a great presentation. Appreciate it.
No problem.
Just a few final notes, I guess. We did do our drawing. Our winner today is Jeff Medor, won our $50 gift card. And again, just a reminder, if you want PDH credits for today's event, you need to make sure that you're registered through our actual website so we can match that up with your PE and PLS numbers. And if you signed in as a guest, you definitely need to make sure, or called in our phone number, that we line those up. Ian, are you still on the line? I just want to verify that up until I think this event, all the PDH receipts for you to keep track of have been sent out to the attendees?
Yes, up until today, all PDH have been sent out. So if you are missing one, definitely email and we'll get that up.
Yeah. So. Okay. Jordan, I don't know. There's a few more questions I think that popped up, but I guess want to make sure people, if they needed to go at one, they could go. If you want to stick around for a minute, and
Yeah.
This episode is recorded. We'll be posting it. It should be up within the week. All the other previous presentations should be up. So I appreciate everybody calling in today. And there should be, we do have another event planned for next week. I want to say it's the integrated project delivery with NCDOT. Derek Weaver will be presenting. So the invite might not have been sent out yet. It should probably be coming out a little bit later this week. So be on the lookout for that.
All right. So looking at another question in there, I see there's one about how resurfacing is handled in the corridor model. So in SS2, you had used cross-slope optimizations and vertical adjustments. So that's going to be handled through the template. So that's not going to change a lot. So when you're creating your template for resurfacing, you have, an option to use a component that's a stripping and overlay component. So I believe that's probably the same in SS4. I'm not sure about SS2. But with that, that's going to allow you to do some of your vertical adjustments to the alignment based off of that. So you'll still be able to do that in a similar manner. Don't see any other questions, but I'll hang out for a little bit longer if anybody wants to stick around and comes up with anything, okay?
Yeah, wonderful. Thanks everybody for joining us today. All right, Jordan, I appreciate your time and we'll let you go.
Thank you. Thank you, Patty.
Thanks, everybody.
Have a good day.